Hello.
Yeah.
Um, yeah, so why don't we explore what you just mentioned, traveling salesman, traveling salesman. What was it? Ant algorithm.
Yeah. Swarming ants, I think.
Okay. I want to do in Rust.
Mm-hmm.
I want a visualization. So I found this Rust thing, which is called a console engine, which I thought was pretty cool.
Mm-hmm.
Let's have a look at it. So simple terminal framework to draw things, manage your input. Um, Works on all these. It's like that. Run loop. Looks like your basic
So,
canvas drawing.
so does console mean it's like the terminal?
Yep.
Cool.
Screens. Cool. I don't know what that means. Generating output. So is that different to this engine screen? Okay. Well, let's check it out and like play around with it a bit. Because I think that would be a good, like we could do it just without any visual, just like printing, but
Yeah, visual is much more interesting.
yeah. So let's see what this looks like. Oops. CD console engine. All right. Go run. A bin must be available. No bin, but they have examples. So I think I can do like cargo run example. Drag and drop. Drag me. Hey, look at that. Cool.
Hmm.
That's pretty neat.
Yeah. How big is that example, I wonder?
Hmm. Not that big.
Yeah, that's all right. And it's got the infinite run loop.
Yeah. Infinite run loop. Wait frame. Interesting.
Hmm. I wonder what frame rate they run at.
Yeah.
How would you work that out in Rust?
I guess you could just for every loop, just print out like time and then do
Hmm.
the delta. So you
Hmm.
could just like if you just printed out dog here, how often is it actually doing this out of
Hmm.
curiosity? Oh yeah, forgot how to do Rust. Print line. So it looks like it's like less than a second that that loop.
Hmm. Okay. But not like 60 frames a second or something.
That would print a lot more, right? So how does this work? You've got console engine as their library. You've got a pixel. You've got this for input. This is just importing a bunch of stuff, I guess, which is being used somewhere. Oh, just there. Interesting. So what did we see again? Huh. So the pixel can be a character. Interesting. You just
Hmm.
specify what pixel character you
Is
want.
pixel an ADT?
Good question.
Like a
Struct,
function?
it looks like. Yeah, struct with a BG. quite readable.
Oh yeah. Yeah, that's good. And what color?
Color. Oh, oh, it's all the ANSI color stuff. So
Hmm. Oh
ADT
wait, no, it's
colors.
at the bottom. RGB.
Yeah, so it is an ADT.
That's awesome.
That's pretty cool. This is pretty nice.
I like it.
Let's just go through how it works. So,
Although I kind of wish that the named ones were like synonyms for the RGB values of those.
right.
I don't know if that's possible in Rust. Like in C++ and C, when you make an enum, you can make certain values equal other values.
Hmm.
And that'd be nice to have in Rust. Maybe it's a thing. Yeah, it might be a thing.
Well, doesn't it have type alias?
I don't mean type, but just value alias.
Oh, okay. I guess with macros.
No, not even with macros.
But you're talking about an alias, right?
Well, I guess I don't know what else to call it, but like it equals one value that equals another value. I'm just gonna try it out and then share.
Sure.
How do you print learn bang? Uh, and then it's like brace question mark brace.
Where are you typing this?
In a Rust playground. How do you print out? Oh, it's like colon question mark.
Yeah, print debug.
Debug. Hmm.
What is it in C++?
It's just equals.
Oh.
Yeah, I'm not sure you can do it. Let me share.
So if you wrote something like you store it in a variable, like
This is my Rust. No, like look at. Oh, you just go to like ID one, or like if you can start up a C++ playground, you can have enum ABC and C equals A.
oh, okay. Right. So you just store the like you can have a
So it's just-
class dog
No,
or
not class, but enum.
just for value types or like well, right. Just for enums,
Yeah,
not for anything else.
no, this is
Okay.
just for enums.
So I can do like hello equals
The enum doesn't have any values in it.
sure. And I just give it like some names or
Yeah,
so.
A, B, C, and you can do C equals A in there.
Oh, I see.
So that way C is, the same as A, the same value. You can use them
Right.
interchangeably. And this would be nice for the Rusty nums because you
Yeah, I
could have
see.
these nice names for these specific RGB values,
Right, I see.
and they're actually the same thing. So that if you
Hmm.
wanted to interpolate between one color and another, you can use the name colors, and will just, yeah,
Yeah.
you would be able to match on it as if it was an RGB. But maybe, yeah, maybe that's what breaks it is like maybe match doesn't make sense anymore. I don't know.
Let's
I
just
don't think,
try
yeah, I don't think there should be an issue.
something.
Anything that's equal something else is like doesn't isn't required in the match statement.
So some ADT. So can I do like hello equals cat?
It looks like you can't.
Or some ADT cat?
Yeah, I tried that. Doesn't like it. Unless there's like some other syntax error. Yeah.
Hmm.
I'm starting to think Red can have this.
Yeah, can you specify different options for enums? Like their representation, is it by default like just a value under the hood, like in other languages? Like
I don't think you can specify that in Rust.
hmm, Rust enum configuration. Well, this is part of a crate. Um, hmm. I wonder if it's like, the constraint stuff. Can you put constraints in here where you have like a J and a K and then you say where J is equal to K or something?
Yeah, but that's for generics.
Yeah. But it's like I'm trying to say that you give it a thing of type J. Oh, that's of types though, not
Yeah,
values.
yeah.
Yeah. Yeah. So possibly no, unfortunately. Hmm. All right, so back to this. How does this console engine work? So it's doing this initialization of console engine, which returns a console engine or error kind. So this is one of the APIs. And then it's calling init fill, which is calling init. And this seems to be, yeah, gathering how big your terminal is. So it's doing all that for you,
Mm-hmm.
filling that entire terminal. So it's filling the space. Oh, look at this, target FPS. Interesting. So I could have put
Mm.
target
Yeah, yeah.
FPS. Oh, it is one of these. Sorry. It's the last one. So it's 30 FPS.
Oh, okay.
So if we make it like 200, is it smoother? It's actually, I can't tell. Like the console
I
printer.
suspect the console's like input speed isn't that high,
Yeah.
so you need to have like an automated generator. This should reflect it.
Oh, can't control C this.
He killed it.
Okay. So this is our initialization. And it defines your rectangle and your relative X and Y positions. Then you got the main loop. And what does wait frame do? So wait frame has initializes the capture input, the resize stuff, mouse. It then will elapse. What does elapse do? Self.instant is a time instant. Instant. We'll try to use monotonic. Okay. I'm not clear if this is actually supporting returning like now or something. It doesn't sound like it.
Try print it.
How do they declare it again? So now, okay. Which,
I got an answer about the enum rust thing.
yeah.
They say use enum : a as C. It's
Ah,
like something outside the enum, I guess.
so if I declare an enum
Yeah.
ADT, and then I have an A, B.
Yeah. So we can do like use ADT C as A, I guess.
Like that.
Maybe expected semicolon. Yeah, maybe they're wrong.
Is it within the enum?
Oh, actually, swap it
Oh,
around. Make it ADT A as C.
just C. Oh.
So it's not in the ADT namespace, but at least it's like a. This is like evaluated. Yeah.
Yeah.
Cool.
So this will give me an A if I print it, right?
Yeah, that effectively does the same thing. Although it's not in the same namespace, I guess is the
Yeah,
unfortunate.
like you want it here. Like,
Yeah, you want to be able to say ADTC because it's like these colors, you want to say color, pink or whatever. No, yeah, it's close. I see it used in code of like, actually, yeah, the place I see it used, we have these like um, functions that will take an enum type, and we have this convention where we have like k max value at the end of the enum, which equals the last value. And using that, it can like iterate over all the values of the enum because like it knows the maximum number.
mm. How do you do this again? Derive debug?
That should be it.
Oh, stop. Okay, maybe it was that. So what does it mean when you do bang?
Uh, where's the bank?
If I put the bang here, it's not good.
That's probably. I'm guessing that's. I don't know. I don't know.
Yeah, right.
Yeah, like you sometimes put bang there, I guess.
Yeah, I can't remember when
Hmm.
it makes sense. So we were looking at this, I guess, and we wanted to do instant now. What is it? Yeah, so it's an epoch time of now. But how did they
Hmm.
use it? How did we see it used? So we saw it in the loop, I think, when it wait frame, instant elapse. Okay, that's different. So I guess it's a delta from then.
Hmm.
So if I do this, I'll get the delta maybe. I'm just guessing. We should probably look at the. Oh wow! So it does give you a delta from then. If I do it again, Yeah, let's just read what this is. Turns the amount of time elapsed since the instance was created. Okay, so you do use instant for time deltaing stuff. Cool.
Hmm.
All right. So let's just keep looking at what this is doing. So it's checking whether the time limit, interesting, is greater than the time elapsed. So how is this time limit set then? Oh, okay. So it's one of the
It's a
structs.
duration.
So if we go back to the creation of the thing, when it returns this console engine, presumably it's giving in this init some time limit, which it says here from milliseconds, 1,000 divided by the target FPS. What?
Hmm.
So if it's 30, then it should
Hmm.
only run for 1,000, um, less than a second. What is this?
What's the value that it would run it?
From millis would mean that uh, you're converting it to 1 second divided by the target FPS, right? So that
Uh,
would be,
yeah.
yep. So that would be 1,000 divided by 30. And isn't this how long it should be running, this loop?
Yeah.
So how does it keep running then?
Well, what do you mean keep running?
Like when we're running this example, shouldn't it exit?
I mean, it's in a loop.
I was assuming that time limit was when the loop should end. Is that wrong?
No, that's the time limit of a frame.
Of a frame. Okay, so that's where I was getting it. Okay.
Yeah.
So if the frame is actually more than that, what's it gonna do?
More than what?
The time limit.
It
I guess
should
it just
just
skips.
it'll be slow, low FPS.
Oh, it just doesn't go into this. Yeah.
Hmm.
So it will skip all of the event handling, I guess.
Wait,
Um,
does it use remaining time? God. It,
it's for
Woo!
It looks like it's
There's
for
so
all the
much
event
code.
polling. Like if you are past the time limit.
Modulo time limit as many. Why is it modulo?
Modulo. So if you have, say, like this is your threshold, 300 milliseconds, and then your time limit. The remaining time is the time limit minus the elapsed time. So let's just say that the remaining time is 300 milliseconds, and your time limit is, yeah.
So this doesn't really sleep. This is a spin loop, I think. Unless event.poll. What's that parameter to event.poll?
Yeah, we should probably look into that. Timeout.
I know. Okay, so that's event.poll is probably doing a sleep or something like that.
Whole internal.
Reader.poll.
That sounds like async.
It does, yeah. It probably supports async, I reckon.
But you reckon this is not, well, what is the trait that it's implementing?
It's not
Oh,
implementing anything.
Waker. Is it ASIC?
But this is like impl thingy without any like feature or
Yeah,
whatever.
yeah, yeah, sure.
But it's so close, right?
Yeah.
Yeah, Waker, that's like a, I think.
But
Does the word future appear here at all?
oh yeah, good question. But I want to see if it's like, is it on a separate thread, or is this threaded polling or something? No, there is none.
I don't know.
Well, this is all internal to this library that is for the terminal stuff. So,
Hmm.
like, I think we
Yeah.
can safely say that the frame FES is like protected by a timeout
Yeah.
limit, and the events that it's capturing will also be throttled by whether you are executing too much or whatever. So it won't execute the loop
Hmm.
that is checking the inputs for keyboard, mouse, and resize. Resize being a event is interesting, and I guess that makes sense because it's like it's put on like that high level because it's going to affect everything. So once you resize, everything has to be
It,
recalculated or something.
it is a user event, I think.
Like if I just drag this terminal and do that,
Like you as a user are doing that.
let's see then. Like this should hit this, right? In
Yeah.
theory. Let's see. Oops. Yeah, you can see it at the bottom. I'm not sure if you see that. Slowly.
Oh yeah. Yeah.
Interesting. And these events are from cross term. Are they? No. Yeah, cross term. So there's another library which is to do with like all the under the hood plumbing for the terminal stuff.
I wonder if cross stands for cross-platform.
Cross terminal, probably, yeah. So that was wait frame. I think that's pretty clear. Check resize. Check resize, which is also part of this console engine, is checking whether the terminal has been resized. Note that a resize will occur, but there is no check yet if the terminal is smaller than required size provided by the init function. Initialize the screen filling the terminal. So, oh, sorry. So basically always do this, and when it does do that, it will handle the terminal's change of size accordingly. I guess what would be interesting is like what happens if you don't do that.
Hmm.
And then we resize. Yeah, you can see that.
The canvas would be like the wrong shape. Yeah, there
Yeah,
you go.
you can see it's.
And I have this exact same thing with the HTML canvas stuff. If I don't handle a resize event, then
Oh, okay.
it'll be the same size as what it was before, and the window is different.
Yeah. Is that an actual window event that you can hook into in?
Yeah.
Yeah. Cool. And then we clear screen. I guess, this would probably take color though, right? Normally. I guess it doesn't matter because, yeah, it's just going to use whatever the terminal's clearing mechanism is. So we're doing some mouse stuff, input, 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 and then the actual draw. So engine has dot rect for drawing some rectangle. I guess we should try and just do that. So let's draw at 0, 0, 0. A rectangle of size 100, let's just say, whatever the units are, I'm not even sure. Yeah, let's just use this. Oops. So this should draw top left a thing. What's this print though? Huh. Ooh. So what's that print thing? Prints a string at this. Oh, so this is for text. So if you want to do more than
That's cool.
pixel based, you use print. So, all right, that's pretty straightforward. So all we need to do,
Yeah, this is a nice API.
initialize the engine. We call a loop, and we need to do the resize thingy. Was that every? Yeah, wait frame and check resize. That's what we need. And then we can clear screen and also call draw and print. Pretty easy.
Mm-hmm.
Let's write
Yeah, this is a very nice API.
resize, and we got some. Here's key press. We got mouse stuff, and we got engine.rect, engine.print. Cool. Now back to what we wanted to do. This thing.
Mm-hmm.
Okay. Oops. Cargo new. Traveling salesman. All right, so let's use our library as a dependency. Cargo search. Console engine, I guess. Copy paste. We should be able to run that example. If not, there's something wrong.
Does it not have like cargo add, like npm can like add to your package config?
Let's see. Oh, yeah.
Mm-hmm.
Mm.
Looks like it does.
So let's say I did that.
Yeah.
Cargo add console engine. Features. Oh, that's pretty good. Because it
Yeah.
tells me features that I could add as well.
Oh yeah.
Nice. All right. Oops. Traveling salesman algorithm ant colony. Oops. Random example. Let's try this one. Okay, that looks pretty promising. Whoa. Someone wants food or something.
They had food already.
Yeah.
Oh.
Implementation of the ant colony optimization traveling salesman role in this project. The Berlin dataset that maps 52 different points in Berlin. Germany was used. Okay. This is Berlin, like, they didn't say what Berlin 52 is.
52 Berlin cities, I guess.
Oh, oh, that's, yeah, that's the actual GitHub thingy. But I just, yeah, is it like based on location? The ant colony optimization algorithm is inspired by foraging behavior ants. The behavior of ants are controlled by two main parameters: alpha, the pheromone's attractiveness to the ant, and beta, or the exploration capability of the ant. Okay? If A is very large, the pheromones left by the previous ants in a certain path will be deemed very attractive, and that was the pheromones attractiveness.
Oh my god, that math expression, Jesus Christ.
I haven't even got to it.
Fuck.
Making the most of the ants of its way towards only one route exploitation. If B is large and somewhat independent, find the best. What was B again? Exploration capability. Okay. So they are like incentivized to explore without, I guess, without pheromone.
Mm.
What's ASIO and calling optimization for used the ant system variant where the movement from node I to J is defined by that. Can we just go through what traveling salesman is again?
Yep.
Traveling salesman. So
I think it's like you got a graph
yeah,
and you want to visit every node in the graph in the shortest distance.
and typically like dynamic programming is the way to do this.
I I think it's one of those unsolved problems.
Okay. So you have like a set of nodes you want to go to?
Yeah. So the salesman wants to go to every city, and it's like,
Right.
how can they do that with spending as little like fuel,
Yeah. So
petrol?
like it's bidirectional
Yeah.
and you can't do bidirectional arrows. That sucks.
Can you just do lines?
Yeah, I could just do lines actually. So there would be some sort of weight for each thing, and each node will have aligned to each other node, right?
Yeah. Oh, I mean it's
Oh, potentially no, I
potentially,
guess.
yeah, not like most places have
Let's just go with
like
that. So it's like
limitations.
two. It doesn't make sense. 100.
Yeah, each line will have some weights of how long it is.
Yeah. Blah 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 blah. So the reason why I thought dynamic programming is because I thought that was like the visual that I have is like you do the two by two, and you're like filling in a bunch of values that then allow you to somehow shortcut the search space, um, like the knapsack roll or whatever.
Mm.
But um, yeah, I guess like the dumbest way would be like you generate all possible all possible routes that you can do from the nodes that you want to visit, and then you just have a total sum, which you're just comparing, and that would be
Mm.
like as many nodes squared. Um, but is it as simple as that in terms of the most basic form of it, or is there something that I'm missing?
I'm not sure if it has the constraint that like you can't go over a path again, like backwards.
Okay,
Might have to look that up.
so we should probably clarify the conditions or constraints that exist for this. So the classic one is given a list of cities given a list of cities and distances between cities, what is the shortest possible route that visits each city once and returns to the origin city, right?
Mm.
So let's say you start here, um, so you want to visit all of these and then end up there. So that is the constraint, is that you have to be back here,
I think it's
or just it's an
and
instance of
return to
this
the
problem.
origin city. Okay, I didn't know about the return to the origin city,
Yeah.
but yeah, yeah.
Is MP properly and combinatorial optimization, blah, 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 blah. In the theory of computational complexity, the decision version of the TSP where the length L, we're given the length L. What's it, length L? The task is to decide whether the graph has a tour of at most What is this length referring to?
At most L. What does the at most mean? Whether the graph has a tour of what? I don't understand the at most. I assume L is like a query, like you're testing, like instead of asking what's the shortest distance, it's like does it have this distance
So
for
you
a
give
given?
it like a distance solution that you
Yeah,
check whether you have done.
you check whether it at most. I don't know what at most means. I don't really
So
understand.
let's say like given these numbers, I'm like, yeah, 250, and you
Hmm.
want to query whether the the destinations and getting back there is a solution. Super polynomially. What does a super mean?
I don't know. Is not bounded above by any polynomial. Oh, okay, so it means it's bigger than polynomial,
Right.
but it's also less than exponential. I
So
think it
it's like it can be any to the power of n, but it's not. Wait. Sorry, not to the power of n.
it's bigger than that.
Just yeah. But yeah. Sorry, to the power of n, and it's not exponential,
Hmm. Which I mean, I guess, sure, yeah.
and is less than.
There's probably functions that exist that grow faster than any polynomial, but not as fast as the exponential function.
So the exponential function, I thought once you, oh, it's like t to the power of some other arbitrary. Okay.
I think exponential is e to the n. Oh, wait,
Okay. So it's
what
using
is
e.
t and what's n?
So let's just say this
So
is
that t
so
to the n, that sounds like, is t a constant?
let's just call it big O, yeah. So like O squared or whatever, but it's like O n, and you're saying that this is less than.
So I don't know you can use O like that. O is not a constant.
Sure, right, okay. Um, like by n I mean like the number of stuff.
Yeah,
Um, so you would say like n squared or whatever. So like n to the some number is a this is a polynomial,
that's a polynomial.
and
Yeah,
then this is less than O to the e to the power of some something like some j
n
or something.
n.
Oh, oh, okay. So it's exponential is just the number of things,
Yeah,
e to the that. Okay,
it doesn't have to be. It can be k.
yeah, sure. Just any number.
Yeah, where n is on that side of the power.
And if you look at like the graphs of polynomials, they look like either the you've got the parabola or you've got the other one. How do I draw? How do I draw? Yeah, so it could be like that, or it could be like that. But then exponential is like, uh, well, I guess it would be like here, right? Like it would be even way quicker.
Um,
What does e to the n look like? Oh, shit.
yeah, let's just graph it. Desmos is a good one for graphing.
Sorry.
Desmos is a good grapher.
Okay.
Yeah, Desmos.
So if I do like e to the power of anything, like 1,
Mm-hmm.
2, 10.
Yeah,
Just sorry. I need to do I guess x. Yeah. And then we go x to the power of 1, x to the power of 2,
Mm.
10.
Mm.
So our exponential, how do I zoom? How do I
Just scrolling, not zoom out.
I kind of want to go translate. There we go. Yeah.
Drag.
Yeah, so our exponential's here. And at some point, x to the power 10 is actually superseding e to the x.
Does e to the x win at some point later?
Probably.
You
It's hard to tell. Can you do like their intersection or something?
need to like scale the graph like by a ton.
Yeah.
Probably scaling options. Use the spanner.
Yeah. So we want to scale
There's no
like
scale.
step. I guess I could do like 0 to.
Oh yeah, 0 to like 4 billion. There we go. So it's still winning.
Yeah. When does it not win?
When does it not win?
Oh, there we go. There we go.
Wait.
Yeah.
Oh
It
Jesus
actually it
Christ.
actually does win at some point.
Can you like change those values like more slowly? Because that was really interesting.
Sure.
And like look at the others, they're flat.
Yeah.
Yeah, I've never seen this view before. Of like it's been so scaled that you see this extreme like
Hmm.
version of it. I feel like it's bugged out now. What's the small value? Is that like super negative?
Oh yeah. 0 to
0.
4
There we go.
billion. So what am I at?
Um,
So
so X is gonna still
4,000,
winning.
10,000.
Yeah,
Oh,
add
sorry.
zeros.
Give me a sec.
Yeah. All right.
Ah, hi. Hi. Can you come up, please? Thank you. Sorry, I'm just getting some food. Just one sec. Yeah, look.
Yeah.
Uh, okay, so 400,000, 4 billion, 4 million, T 400 billion.
Mm-hmm. They're
Where am I
getting
at?
closer. Yeah, they're getting closer now. Yeah, that's so cool.
Okay, well that explains that this
Yeah,
thing. Oops.
and like how did surely when people saw things before, they're like, oh, e to the thing, x to the 10, like, that'll never overcome the other one.
But it does.
But
Exponential is the end game. So, yeah, so it's just saying it is a super polynomial legally. First problem, blah, blah, blah. Yeah. Heuristics and exact algorithms. Okay. Do we want to read this history?
yeah.
Okay, so here we go. Undirected weighted graph. Interesting that it's undirected. I guess that makes sense with this because this is undirected because it can go either way.
Yeah.
So cities, graphs of vertices, paths, and yeah. So this case of like this not connecting to this, adding a sufficiently long edge will complete the graph without affecting the optimal sort. Is that saying that if there is no edge, you would just use a long edge? Is that what it's saying for that? Computing that? Like, we don't know
Yeah,
how the
yeah,
algorithm works, but it sounds like
yeah.
it will
Because
do.
so it won't be part of the correct answer if it's long enough.
So yeah, we can say something like this is like symmetric. We're not going to have different distances, which halves the number of possible solutions. And then, yeah, you can have an asymmetric version. Sure.
Asymmetric would be that if I
Yeah,
guess that would be a
from A to
bidirectional graph where it's different distances but based on the direction,
right. You would call that bidirectional.
whereas an undirected graph doesn't have any difference.
Hmm. Okay, so integer linear program. One labels the cities with numbers 1 to n. So we definitely don't go negative. That's good.
Yeah, generally for these shortest path things, a negative means death.
Yeah. Yeah, so you can get into like cycles where it doesn't end, right?
Yeah, because it can just keep traversing that path to become less.
So it's like the key gotcha if you have, say, yeah, these directional graphs that, yeah, then can like cycle that they should not have any negatives.
And I feel like it need to have a graph with cycles in order to do this problem. Otherwise, you can't get to everywhere.
Otherwise, it's just like linear, one to the
Now, it
other.
could be a DAG.
Hmm?
It could be a DAG. or like a tree.
Yeah, true. Like it could go like I was just thinking of the basic like if none of these were connected and then F goes back to A, that the most simplest version of that where you're just like and then you go back. But
That's solvable.
right.
But if it's like a tree, then it's not possible to solve.
Well, you have to go back to the origin based on this thing.
Oh, I
So,
guess I was thinking of a directed graph.
oh, okay, right.
Yeah, like a tree where you go forwards and you can't go backwards.
Hmm. Yep. So the point of doing this, where we have like this Boolean state for a particular edge, um, and we're just
What's the
giving it
name?
a value or one. Yeah, 0 or a 1.
From city. Oh, right. Yeah, that's like the matrix.
Yeah.
Hmm.
So it doesn't actually account for the weights yet. It just has
Yeah. Yeah.
the the minimal tool length is just saying whether you can go
Mm.
to these, yeah, to through the edges back to, yeah, for all possible things. So this is your
Hmm.
2D thing. And one base, so I assume, so like starts at 1, not 0. So this sentence is interesting. Well, maybe, do you want to discuss any of these sentences or are we good?
Because these are zero variables, it becomes integer program. Yeah. Minimize. C is the who? What was D?
Um, C is like
To be
the,
the
let,
distance.
yeah, city I to city J, and the city, it does, yeah, I guess this is saying the distance because it doesn't actually state it, but I get,
No, Xij is the answer. That's going to be whether you take that path.
oop, sorry, you were saying?
So X is like the output solution. Very nice. Yeah, X doesn't describe the graph, it describes the path that the salesman is taking.
Doesn't describe it. So the current path
Or
that
the
it's
final
taking?
path.
Oh, the final path. Oh, so yeah, if you, hmm. And it will encompass like the other cities as well within just like a specific I and a specific J? Or just
That's for all IJ.
okay. Where where's the thing? Oh, is it this? Right. No. Uh-oh. Sorry.
Close it.
I don't know where it went. I think I did accidentally.
Yeah, so X is like the output. This is the path.
I read this as one city to the next, not all of
Hmm.
them.
Yeah, but it's defined for all IJ.
in here.
Just in general. Like it says x of ij.
Yeah. So let's
So you can
say
give it
in
any
this
pair of
node,
cities to give you the value.
say that again.
You can give it any pair of cities and it'll give you a value.
Yeah. So
So
if
it
let's
is
say like we
divisible.
do um, A D, okay.
Yeah.
Um, this is saying that AD will either be 0 or 1
Yeah.
if the path goes from A to D, which it does.
I mean,
Hmm?
we don't have an answer for x to. What's the answer? What's the path that this traveling salesman is taking? When it says path, I think it means the path of the traveling salesman.
Okay. So is this actually describing more than just whether there exists a path, but whether there exists a path where the traveling salesman can reach
That's right.
every city?
I think C is the whether there exists a path.
This C.
Yeah.
Um,
That's why they're multiplying it. That's getting the total distance of the traveling salesman.
okay. So when you say there exists a path, this value here, is that like a total or something
The
of the
Cij.
distance? Yeah.
Cij is the distance between I and j.
Yep.
And Xij is like a bool of whether the salesman took that path.
Yeah. Yeah, right. So I think we're on the same page. It's just more like the way that you just expressed that. But the X is just to say whether it did take that path,
Yeah.
and the C
Like
is to actually
output.
account for the distance, like accumulated at that point, I guess. No, or just
To
between two
me,
edges.
C is the input to the problem and X is the output.
So it would be one of these, right? Like it can only be one of these values, the weight, or is it an accumulation?
It's an accumulation. It's a sum.
You're taking this though, right, to do the sum, but I'm just talking about the individual values, just
Oh,
a
you mean
single
just
weight.
the B? Yeah, yeah. It's one of those edges
Yep.
distances.
Yep.
Yeah.
Okay. So this is quite brute force then, just by looking at this, where it's
This doesn't have an algorithm. This is just defining. This is like saying, here's an equation, solve. Solve for the minimum sum value of these.
right.
I guess it is brute force in that, like, you could try every possible definition of x and find the one with the smallest value.
Yeah, which is what I initially said would be the way you would do it in the most dumbest way.
So what complexity would that be? That would be uh, I feel like that would be like 2 to the n squared.
So you definitely have to go through every common permutation, um, and you wouldn't include yourself though. So it's like once you go to one node, the possible nodes that you can travel, let's say, you wouldn't go back to yourself. You have to go to n minus one, right?
I think it's still a n squared type of. So the imagine this x definition. If you want to try all possible values of x, all possible definitions of x, one x is like n squared size. Like it's technically not n squared. It's got to be minus
Mm,
something because you're
sure.
removing diagonal. But in terms of complexity, like it's still a square.
So it's like you've gotten a route, and the worst case would be like every single node. So let's just say it's that. Wouldn't it just be
Wait,
like max n
no,
then?
sorry, what do you mean by worst case?
Like you're saying this is technically n squared already,
Hmm.
um, because it encompasses the traveling salesman's route, right?
No, it encompasses every pair of cities.
That the traveling salesman would go to get to resolve this solution, right? To go
Could
back to the.
could possibly go to.
Hmm. So I think what's confusing about our discussion though is that the the formula here is doing that, not just the x. And I feel like the way that you've communicated it is that this single value um, sort of represents that, which it doesn't, right? It's the summation of the potential x's that it would go to. Let's say it goes A, B, and then B, F. That's one way, and then E or whatever. Like that's this.
Those sum adds up the total distance that the traveling salesman goes to. It doesn't like it throws away the actual path itself and gives you the distance of the path.
Maybe I'm not communicating this right, but in terms of like possibilities, like just with this graph, you could go like A, B, F, and then E or whatever.
Yeah,
Does that represent one version of this, or are all permutations represented in this one equation?
that represents one value of x. Some given path that the salesman took. That's one value of x,
One value of X.
or one definition of x, you could say.
Okay. So in this equation, one value of X represents that, is what you're saying.
Is the path the traveling salesman took. Because the xij is that's defined for all cities, all pairs of cities.
Right.
And so it encodes the full path that the traveling salesman took by just saying for every pair of cities, did they travel this way or not?
Yep.
And it's directional as well. It's from CDI to CDJ. So you can do the reverse as well.
Mm.
But think of how you would store an X in data. It would be like a matrix where like the row is a city and the column is the other city, and then every single cell is like a 1 or a 0.
Yes.
And then the xij is just querying the value of a cell.
Yep.
And so that's an n squared size already.
Yep.
And then every possible permutation of that matrix is like 2 to the power of n to the power of 2.
Yep.
Yeah, that's where I get that
So
complexity.
two, yeah. The two to the power of n though, where you got that because you want to try and find
Every cell is either
every
0 or 1,
every cell is 0, 1.
and there are n to the 2 cells.
Yep.
That's where I get it.
Right. I think that makes sense. Just to have a ballpark idea of like how many permutations and stuff you need to attempt. And this is
And
is
this
this
kind of makes sense for the super polynomial because, like, there's no polynomial that's going to be bigger than to the power of n to the power of 2, Wait, but that's even worse than exponential, isn't it?
N to the power 2.
Yeah. K to the n is not as bad as k to the n to the power of 2. That's like a polynomial in the exponential.
Right.
They've combined. Anyway, you were asking if these sentences made sense to me. They do now.
Okay. I would say I'm like maybe 60% in terms of confidence in this. Um, Let me maybe reiterate what I understand.
Yep.
So, yeah, I can see like the table or 2 by 2, sorry,
N
n
by
by
n.
n table that shows whether you travel from one to the other.
Yeah.
And there would be many permutations of that, which
Yeah.
encompass the traveling salesman's route. Um, Now, with that table comes with the weights that then will accumulate to the length that you are touring.
Yeah, that's like a
And
separate table of just distances between cities.
yeah, and the
The
minimum of
summation is
that
like
would be
multiply
the
them
better
together.
answer.
Yeah.
So what I'm not sure of is this minimum tour length, is this describing the minimum of all the tour lengths from all those tables that I've just mentioned, um, all possible tables that exist um, for the traveling salesman, and just find the minimum. Is that what this is describing? I just want to sort of.
Yeah.
Okay,
Yeah.
cool.
When it says minimize, I think it means choose a value of x such
Yep.
that it's the smallest value.
And so, because it's going through each value in the table and its weight that exists, when it's obviously one, it's it's going to combine those to get that value, and then yeah, find the minimum of those potential
Yeah.
tables. Um, that's
I
what I
guess
understand.
it's like what you might call the evaluation function.
Sure.
If you were to throw this at AI, you'd be computing this value all the time to see if it's the current solution is better than the previous solution.
Hmm.
And I guess if this was like a different program, a different problem or a different equation that wasn't so like Boolean,
Yeah.
you could like find derivatives and then go, okay, let's just find where the derivative is 0, and that's where our minimum is.
If it wasn't just like I'm traveling from A to B and some number,
Yeah, it was like more continuous
right?
math problem.
So like it could be that I travel a certain percentage or something. I don't know. In
Yeah, it would have to be something continuous that you
Yeah.
could do derivatives on. That'd be really interesting to come up with, like a continuous version of this.
Well, maybe the problem can be sort of defined in continuous way where you could like
Mm.
travel like a certain amount and then like backtrack, you know, or
Is
go.
it be like a continuous approximation of the problem? Which is weird to say. Normally, like the discrete things are approximations of continuous. So this is like go the other way around, create a continuous version of a discrete thing.
Well, I was thinking like these edges, right?
Mm.
Maybe it's defined such that you could travel a certain amount along the edge, and then new edges form from that point
Mm-hmm.
to each of the other cities that might
Mm.
be um, that will have different like obviously different weights, but you're sort of having to do more objectives, maybe like these like midpoints or whatever are like new cities or new destinations that you have to go to, and
I feel like we can't get around the fact that there's a discrete number of cities. I don't think that part can be made continuous, and that will be like a Yeah.
All right. Well, what does the next thing say? So without further constraints, the set of xij, ij will, however, effectively range over all subsets of the set of edges, which is very far from the sets of edges in a tour, and allow for a trivial minimum where xij equals 0. I don't really understand that
I
sentence.
have no idea what does very far mean. In what kind of sense? Far sets. How is a set far away from another set?
Like in terms of the number of edges in the set, like more.
Maybe. Yeah, like the size.
And then they just introduce this trivial minimum where all ij is equal to 0.
Oh, okay. Yeah, no, that's true. That's true. So if we just had our thing as is, like to minimize the tour length, you just set it 0 everywhere. That's true. So there does need to be another constraint which they're going on to. Like everything needs an incoming and outgoing edge. Exactly one incoming and one outgoing. Oh, okay. Well, that kind of suggests you can't like go to a thing and then go back. Yeah. So you can't go to a city more than
Right.
once.
How does
Yeah.
that correlate to the 0 thing trivial minimum setting?
I'm
I don't
not
know.
sure. I don't know why it needs to be exactly one. You'd think it'd be like it'd be at least one incoming edge and outgoing edge for every city, because that's the visiting part. Every city needs to be visited.
Yeah.
But I don't know why exactly one, why that's necessary. But yeah, that's the constraint that I think I wasn't sure about, and now we've got it.
So the constraint is that you just visit the city ones.
Yeah, one incoming edge, one outgoing edge per city.
Hmm. Well, that definitely reduces the sample space of tables.
Mm.
Um, oh, and I guess it means that, yeah, like if this, for example, doesn't have an edge, let's say it wasn't connected, what happens when they can't visit all of the cities? Like it's impossible.
Mm. So that kind of puts a constraint on the graph.
Yeah, that they must be connected somehow
Mm.
with one incoming edge and one outgoing edge.
Yep. Do you want to like start coding this? Like, maybe not the
Sure.
solution or anything like that, but just like the graph.
Yeah.
And like, I feel like with this information, we could even just create a random path that satisfies this one incoming edge, one
Hmm.
outgoing edge constraint, and just draw it.
Okay. Yeah, I'm just finishing my food. Just give me 5 minutes.
What do you get?
Some noodles. Ah, do you still have like tummy ache from the thing?
Nah, I'm all good now.
Okay. I think it
My
was the
Sunday was
food.
like ruined.
Huh?
Yeah, probably. My Sunday was ruined.
Yeah,
Like,
sorry about
I was in pain. Oh,
that.
you were as well?
Not me, but yeah, I think it was the food.
Hmm. Yeah, I threw out the leftover pasta, but I kept the pizza, and the pizza was good.
Right. Fair enough.
I feel like it was like just sort of the whole weekend, even
Oh yeah.
just the restaurant food.
Fair enough. Yeah. Um. Okay, so if we were to make something, um, then we have to have a representation of this
which can come in the form of either the 2D set that has like whether there's a one,
Mm-hmm.
whether there is an edge that goes from like one city or the other. So it would just be like a 2D array.
I'm kind of inclined to just start off with every city can go to every other city,
Okay.
and then random weights.
Yeah. And I wonder if like instead of having to stick with the array API, whether there is inbuilt stuff for like a matrix, that might
Mm-hmm.
be like easier.
Oh yeah.
Because then you could
Yeah.
just do like matrix of ones and stuff like that.
Do you think there's NumPy for Rust?
I don't know.
Mm-hmm. Num Rust, oh yeah. NumPy.
It's
Because
the
are you familiar with NumPy, I guess? Like if you would use that as your matrix thing.
um I would have to look it up, but yeah, I've used it enough to kind of know what to do.
Hmm.
But would that be sensible to just kind of use a matrix API instead of like the array API if we're gonna do this?
I think either way is good.
If we're gonna just do raw arrays, what are we keeping? We're just do the array of like ones and zeros to say whether
We just
they,
have a vec of x
yeah,
of numbers, I guess.
and it's just to say whether, yeah. So we generate like this 2D vec thing that randomly is of size n, is of size n, and I guess we just randomly generate or just say that they all visit each other, so it's all ones. So it's ones
Mm-hmm.
and zeros as visiting. And then as a separate array of x, we need the weights to say like from one to the other how big the distance is. So we need two forms of that.
Yeah, we need the location of the nodes for when we draw it. So I guess the distances could be like real distances.
Okay. What do you mean
Because
by
if
that?
the nodes have an xy value, then like we don't even need that n squared like distance thing. You can literally just do Python.
Sorry?
Like if you just have coordinates,
Yeah.
then you can just do Pythagoras to find the distance.
Oh, you mean when we draw it and stuff?
Or even to like you can remove one of these matrices. Because to find the distance between two nodes, you just do Pythagoras instead of a lookup.
Right. Okay. So we just like have the distances.
Yeah. I'm inclined for that because when we see the answers, we'll be able to tell like that it's correct,
Right.
sort of visually.
Okay. Sure. All right. So vec2. Let me just do array. Let me do this. See if we can remember. So vec of some f32, I guess. And this is our distances. Let distances equals, and then vec new, and then we need another. I guess you give it a size, so num cities. How many? Yeah, so let's go 10. So this is generated 10 by 10, and then I guess for the distances, they're going to be symmetric from one to the other, like in terms of like A to B and B to A, right?
Yep.
What's the vec? Do you give it a length? No, you just say new. And then how do you push into a vec? You just do distances dot push. We want to push a vector of all the corresponding things. So
This makes you wish you had list comprehensions.
Yeah, is there like what's the closest thing you can get? I guess
Because Rust has range, right, Arjun?
yeah.
Can you collect the range into like a
Collect,
vector?
yeah. Rust range collect vector.
It'd be like range, map it all to 0, and then collect.
Hmm.
Yeah.
So you give it a range for 1 to or 0 to I guess we'll be 0 based.
Hmm.
And this is inclusive or non-inclusive, I don't know.
I think it's exclusive.
Yep. And it is dot 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 inclusive then?
Does it have dot dot dot? I think it's dot dot equals if
Right.
you want inclusive.
So if I let v equals range 1 dot dot 10 dot and then we'll just map
That's
um
exclusive, so it's going to have 9 elements.
yeah, sorry, 0 to 10.
Yeah.
And for each one, let's just multiply each one by 2. So we expect to have 10 elements, where the last one's going to be 18. So I give it a lambda, I guess, x times 2 dot
Hmm.
collect.
Yeah. Print.
Type annotations
Type
needed.
and pieces
Like
there. Oh, yeah, yeah. Makes
32, I
sense.
guess. Can that be as a an integer?
That's where we need the map, the thingy from.
Which one?
In those examples,
Oh,
where we got
right.
the 42 from. Which
Oh,
makes,
right. Yeah.
well, I mean, you could do that in your lambda there. You could say x times 2 as f32.
Oh, right. Yeah. Nice. Oh,
Yeah,
no. Oh,
you need
X
brackets.
has to be. Oh, right. Right. Oh.
User, yeah, cool.
So, yeah, this is kind of close to
That's pretty much, yeah.
what we want.
No,
So
that's
we want. Uh, yeah, where was my thing? Was it in this? Oh, yeah. Sorry. Yeah, so we want to get rid of this, I guess, for now. F and main. So we want a vec. So how do you want to associate the values of the cities?
values
Nums
of the city. What do you mean?
of because the distances, right? So for like 10 cities, we got to generate some weights just randomly, I guess.
We could give the cities coordinates,
Yeah.
and then for every pair of cities, you can just use Pythagoras to get the distance.
Yeah, sure. So, um, what's the best way to do this? I guess you have a coordinate vector,
Yeah.
let cities coordinates, and then we'll just credit the, yeah, how do I do the brace notation for vec? Oh, can I just do that?
I don't think you'll
One,
be able
two,
to do
three,
brace
four.
notation because we want it to be. Oh, do you mean to put it in by hand?
Yeah, 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 yeah.
Yeah, okay.
And so we'll have a struct of xy coordinates, which is
Hmm.
going to have an x in
I wonder
there.
if like Rust already has like points as a thing struct.
Where would it be though?
Either point or like vector. I know this is not vector because vector. Thing. Yeah, it doesn't think they have one.
Yeah.
Okay, that's kind of a shame. I feel like languages today should come with standard vector libraries.
I mean, Python doesn't even have one, right?
Yeah, it's weird. Python at least has complex numbers. Yes.
Right. Do you specify a type for this bang? Like, do I need to say,
I don't think so. I
or
think
do you
it
just do
infers
it
it from the
here
values.
like that?
I think it infers it from the values.
All right. But
So
how would it
if you
know
just start
that?
putting structs in there, it'll become a
Right,
vector struct.
right. Okay, let's try. 2.0, 2.0. Expected
Give
identifier X, Y. Yay! All right.
Yeah.
And oh, we should make this an enum with this so we can give it a name. Can we do that? Like city.
That would still be struct, I think.
Right. Yeah. So we'll just have city name string. I'll just use the object string, and then xy is xy. City name a xy equals xy xy. Yeah. From string? No. What is it? String from stir a.
From?
Oh, is it? Yeah. Cool. So yeah, let's just make this at the top left easy, and then we'll make this one like be sort of 50, and we'll make it so y will be positive down, I guess, if we're talking about like similar to canvas.
Probably, yeah.
So we'll say 50.
But these aren't pixels. These are like character sizes.
What do you mean?
There's like, how big is your terminal size?
Yeah, I don't know how they translate 0, 0 and whatever, like in terms of position.
It would be by character size. One character is one.
Yeah, and the character size in Unicode is they should have like a certain fixed size.
I don't think you'll have 50 characters vertically.
Too many?
Yeah.
Right. Yeah, I can't really tell. So, yeah, this is
Like you
one.
can see in your editor, like
Yeah,
line 19,
yeah.
that's 19 already.
So we probably have like max in terms of like this box anyway, like would be 20.
Yeah.
So let's put it 10. And then going this way, it's a lot more. But let's say it's like max 30. So we'll just like say
Yeah, I reckon
15.
horizontally it'll be like 80 or something.
Yeah. So we've got one here, and then we got one sort of like,
Oh wait, much more than 80, because like horizontally it's shorter as well.
yeah,
In
it's
addition to having way more spaces, it's probably like 200.
so let's say 100,
Yeah.
and then we'll put one hopefully towards the end, so like 20, and then we'll make it back at 0. So this should like, if we did draw it,
Yeah.
have like a triangle like that.
Yeah.
So when you say get the distance, yeah, we could just like do Pythagoras.
Have a distance function between cities.
So let me just draw that triangle so I can. So we got our console, and yeah, we have like this, where our points are like there, and there, and there. So the distance function is final minus initial. To get the length, though, you just do the square root of a squared plus b squared. So so you do I just need to get that length right. So it's just finest minus for x, finest minus for y squared for both, and then you square root the thingy.
That's it.
Whoops. Oh, this is something else. How do you use square root?
I would do to the power of a half.
Ah, yeah. And let's just confirm that. Let's do math at RS. That power is
Was it a 3, 4, 5 triangle? You test that.
3, 4, 5, right? So, like 3.
One edge is 3, the other edge is 4, and then the hypotenuse is 5.
Yep. So you mean like a square triangle,
A right angle triangle.
right angle triangle, where 5,
Yeah.
3, 4.
Like that, yeah.
So if we did, um, yeah, we're just doing 3 squared plus 4 squared to the square of 0.5. Oh, yeah. Oh, is it this? No. How do you square? How do you to the power of?
Double asterisks, I think,
So I did.
but not consistently.
Sure. So it has to be
Yeah. Maybe it's not that.
I don't think it's that.
Yeah, how do you do it?
I think it's like stood pow or something.
Is it really? Oh, do you remember when we left this stuff?
Yeah, it's like really, it's really
Dot
verbose.
code, dot sign, dot thing.
Yeah,
Well,
right.
I feel like that wasn't the only way. I think they also had free functions, but still. In this case, dot power is fine.
Right. But I want to know what the alternative is. So they don't have infix versions of it from what we remember. So you got to do like 3.0.pow. Oh, all right. Pow I, pow F, and I can give it to.
Yeah. And then you probably have dot square root.
Oh, hmm.
No?
Wait, does this work? Really?
Huh?
What?
Uh, maybe you need to make X a type.
Right. Hmm.
What? Seriously? So like you have to do 3 as F32 dot pow. Brackets, probably. Jesus Christ, what is this language?
Nah.
How did they decide
Nah.
this not be right?
Nah, that doesn't seem right.
So how do you square a number in Rust? How do you square? You know what the problem is? We're using literals. Like, who uses literals?
Sorry?
We're using literals. Like, no one uses literals. That 3.0, like, that doesn't. I don't know. We normally use a variable there.
Sure. So you're saying that it's but
This is probably
right,
an
I get
implementation.
yeah, I guess
It's still gross that this is meh.
right,
Still not sure if this is really
right.
the way.
Okay.
But at
Well,
least in like real code, that's unusual.
sure. Okay. Let's just call it that then.
Mm.
So we want a dot x minus a oh sorry. We have final minus initial. Let's assume that b is final, I guess. B dot x
In this case,
minus
it really doesn't matter because you're squaring it.
oh yeah.
But yeah, final minus initial is a nice thing
Sure.
to maintain.
Sure. Yeah. So we want to square this, and then we want to plus it with a dot y, pow I2, and then we want to dot pow f,
This is not have square root.
root, yeah, sorry. Is it arrow? Yeah. All right. So that's the distance, and we should test this by copy pasting this and trying.
Let's just print the distance from like CD8 to CD
Well, I'm just gonna do. Oh, fuck. Yeah, sure. I was gonna copy paste and then do this thing. Oh, I guess it doesn't matter. Sorry. Yeah, let's just distance between cities dot 0, 0 and cities 1. Is not correct because it needs the XY. Oh shit. Oh
Get a reference.
yeah. This? No. Oh yeah,
Yeah.
so I can give this a reference to
Yeah.
that and that.
Mm-hmm.
And then we print and
Okay. Ooh, what?
huh?
What? Are you running a different program?
Oh yeah, it was
That's the number.
149.
Wait, is that right? That doesn't seem right. That's not right.
No, it should be like um
Do you think Howie returns an integer?
maybe. No, it
No.
doesn't. Maybe it
I can't see what's wrong with that though. Maybe it really is 100.49. Like let's do the math on the calculator.
sure. It's using Python.
Python.
Yeah, so if we did 100 squared minus plus 10 squared square root.
That is hang on. That's not squared is double asterisks.
Oh, what's this?
That would be a bitwise operator.
Oh, right. Yeah. Oops. Thanks.
Yeah, that's more like it. Oh shit. Well, okay.
And I guess that kind of
Huh.
makes sense that the length is somewhat, it's going to be at max, yeah, like 0, 0,
What?
and it's slightly,
What? But like 0.49, and then you get an extra 10 in the thingy axis out of it? Huh. Okay. Yeah, okay. Okay. Sure.
okay, so are we saying it is that? And
Yeah. I'm convinced.
yeah, okay. So we wanted that so that we could compute the distances between
Yeah.
stuff. But what else do we need? We wanted, what else did we want?
Draw
Um,
it.
yeah, so let's try and use that thing.
And we can like draw all the lines between all the cities.
Hmm. How do you draw?
Assuming it can draw lines. I don't know. Can it?
Yeah, there's a lines example.
Yeah.
Let's have a
But
look.
like what's the API? Is it nice? That's lines. Wow, that's
That's pretty
ugly.
cool.
But so it's got random pos, line, pos one, pos two. Cool. Engine.line.
If they use this instead, maybe it would look better.
Hmm.
No. Or just a dot.
Better. I reckon it's better.
Or a dot.
Or dot, yeah. Eh,
Eh,
it's got to be like relative to the line direction.
yeah.
Yeah. And that'd be a nice like thing to
Yeah. Like changing the character based
selecting
on.
the character based on the like slope.
Yeah. Otherwise, yeah. Yeah. I'm just gonna try this as well. X. Eh. Anyway,
What you want block?
yeah, the block character, whatever that is, like this.
Yeah,
Can it do Unicode?
we'll find out.
Oops.
Oh yeah, try like happy face, like an emoji.
Hey, look at
Oh, that's good. That's good.
that.
Yeah, yeah, do emoji. Do emoji.
Yeah.
Do snake.
Cool.
Nice. Nice. Oh, how good is this? You can use emojis. You can just start. You can like we can make a game with this. Where
Yeah,
it's like
totally.
emojis jumping on platforms and things. Like there's probably like a brick wall emoji,
Hmm.
and like grass emoji, tree emoji, and like stuff for enemies.
Oh
Like
yeah.
there's ghost emojis and alien emojis and fireball emojis. You got everything.
Hmm. Yeah, totally. We could make that would be a good
And heart
Rust
emojis for health.
like project to kind of like do recreate that game that we made in that Java game thing, like the tile based one,
Yeah, yeah,
where
that's
you
great.
have like yeah, you have like blocks and you can do all the tile based stuff with just emojis.
And I'll do the Carmageddon again.
Yeah. Okay. So we started our thing. And we just want to draw a line from this point to the other point, see what happens. So we'll copy paste this. So we want to draw it for every, like every combination, I guess.
Yeah.
And yeah, so
With this, like for I and thingy,
hmm,
how do you make sure it's like a reference versus a copy?
yeah, good question.
I don't know.
Reference. I think it's based on the way you do this iter.
Yeah,
So iter already does reference.
either is referenced by default, and there's probably like a different version which is like, yeah, it's drain. I think drain is like dump all the stuff out, and then just like move it out in the for loop.
Hmm. And you can't check whether the references are the same. So
I can. I don't see why not.
so why is it saying that it can't be applied to this then?
Try on pointers. Ampersand.
Oh, right. Oops. Yeah, not dereference. There is. Hmm.
Oh wait, that's not pointer. How do you get pointer? Is it like dot pointer? Or is it as how do you get pointers? How do you compare references? Uh,
Const.
as so we do I as pointer to CD. Yeah, equals J as pointer to CD. Pointer.
Oh, sorry.
Yeah. Does it work? Expected or const?
Do I have to say
Oh, you
const?
have to be explicit
Oh.
about const. I don't like that.
So if I didn't do that, it's saying it's a mutable pointer.
I think it's you have to specify. You can't not specify.
Right.
Which I don't. I don't know why they have that.
Hmm.
That's pretty verbose. Like I'd be tempted to write a generic is same or something,
Right.
or even like
Um.
technical is.
Hmm. So I just draw the 2 points now. So I dot x. Do I have to? No, I should be an actual city now, right?
That's right.
So it should be that.
Yeah. You might have to add. Oh, is it happy? We'll see.
Then you give it the pixel.
I think it would take X Y X Y.
Oh yeah. What happened there? J in the scope. Huh?
J is in the
Oh,
full.
oops. Yeah. Hmm.
Mm-hmm.
And then we need a pixel. Let's copy. Whoops. Just want to copy this. I'll just keep it RGB. So the values of this can be U8. So,
We can just use a name color like white.
oh, true. True. Yeah. What else do you need?
Seems pretty good.
Oh, right. As I32. Fuck. So they have to be int.
Makes sense.
Cool.
Cool.
Unnecessary parentheses. Oh yeah, true. You don't need parentheses. Too much JavaScript. Overrun.
Carol. Nothing.
No. Let's just draw a line.
Yeah.
Engine line 0 as I32. Whatever. Let's go.
Do you really need to do that for this?
Nah, it doesn't matter,
It
but
should be able to compare it.
it should. Yeah. All right. Fair enough. So 0 to 50 down, and then, oh no, not 50. Let's just go 0, 0 to 100, 100.
Yeah.
And if it doesn't draw anything, we got a problem. So,
Line. Maybe try.
Oh, draw the screen. That's what I was missing.
Okay. Interesting.
Hmm.
So it has like a buffer before it
Yeah,
draws. Okay.
fair enough.
And then does it need like a clear screen as well?
Yeah, true.
I think this one doesn't do it. The lining before. It was just going on top of itself. Yeah.
Hey.
Very. No.
I can't quit. I need to add the thing, the Q thing.
Okay.
Can I do like quick fix? Yeah, nice. Okay. Check it out. Check it out.
That's a triangle.
Yeah.
That's very nice. It's like a flag.
Let's just add some random stuff now.
Whoa,
That's cool.
That's awesome.
And the resize works.
Nice. Nice.
It's very nice, this library.
Mm.
Yeah, cool.
Nice.
So we've drawn it. Drawn lines at least.
Mhm.
And
Yeah, this is a good like Here's the graph, and
Yeah.
then on top of this, we draw the solid blocks for the paths of the salesman.
Yeah. As like different colors or whatever
Mm.
to represent. Yeah. Yeah, this is good. Like having the actual algorithm be visually like we can even draw
Mm.
all permutations like for each
Mm.
thing as an animation or whatever.
The loop can be like generate an answer, draw it, and then
Mm,
just do it again, and then you just get this crazy flipping through
yeah.
path.
I think that's what I want to achieve, like just having some fundamental problem, having a visualization, and then we can build upon it. But like I think this is a good place to sort of like hang it,
Yeah,
where we're at. But
we
like
could have like generate a random salesman path, and if it's better, then keep it. And so we're showing both of them side by side, where the best
mm,
one's on the left and then the random one's on the right,
oh
and
yeah.
we see it improve over time.
Yeah. Yeah, that makes sense.
And that would work with the ants thing as well, because the ants is like an iterative
Mm.
solution. You keep your best thing, you keep improving it.
Yep.
Yeah.
Oh, nice. Nice. So we learned a couple of things that
Yeah,
comparing
quite a few things.
references require like that const pointer explicit as thing.
Yeah, that's weird.
Otherwise you're comparing the values, I
And that
guess.
math on numbers in Rust is horrible.
The math is horrible. This console engine is amazing.
Yes.
Um, we learned about the traveling salesman thing and how as it's super polynomial but not exponential, and the reasoning there is like if you look at all the permutations of every traveling salesman, yeah, it will become something like um, as many. How do I describe it? So like so each permutation is going to be almost like part of the 2D or 2D grid, and so you can have potentially like n of those, right? Or less.
Mm, say it?
Like the number of potential traveling solutions that you can have. Um, you have you would have like the 2D array, like what we're generating for points from
Mm,
one city to the other. They can
mm.
you can't travel from you have to travel to at least every city, but
Yeah,
you
that
only
actually.
travel once to each city, and you also have to get back to the origin.
So that
So
greatly minimizes the thing to be like, um,
it's not n by n that
yeah, every
that thing.
city
It's
has
like
a city that it goes to from it. So it's like it's just n at that point.
yeah. So it's not like a table of every
Mm.
permutation. It's just like a particular city that you're going to. It
Mm.
has to go through there and complete.
For each city.
Yeah. But I
So that's
guess you
like
start with the n
10.
by n and then reduce it down to try and find what the complexity is, I guess, for that.
But still, like now the possible values that a city has of where to go to is still like n. So it's still kind of like n by n.
True, yeah.
Mm.
But in terms
Mm.
of how many of those, what is the maximum amount of permutations you can have?
That's harder.
So is
It's
that
like
is that
you
n?
can't have
Like,
two cities go to the same city, for
yeah.
example.
But you could
So
say like 2n as like a ballpark, right?
I don't know. Like the
Okay.
number of permutations of these cities, I feel like is going to be more than 2n. I'm
But
not sure.
less than mm,
I feel like it's probably like n squared divided by something.
mm. We gotta try and think about that one. Um, okay. So
'Cause
we
that,
kind of
that
got
feels like random selection without replacements or something.
right.
The first CD can go to any other CD, then the city you go to can go to any other city minus where you've been.
Yeah, and
And that still feels n squared to me. It's like the triangle. It could be like n minus 1 squared on 2 or something like that.
yeah, I remember in probability if it's without replacement, there must be like a formula for that, which I'm kind of thinking is similar to like, the bang where you do like one, each thing is multiplied by plus, plus one up until n, but like you want to do it in the reverse with minus whatever that is, where you're like minusing the thing without, so that you're not replacing it back into the pool of permutations, but you are
Right,
reducing
there's
it.
a factorial.
Oh, can you
N
just do n
factorial?
minus 1 factorial? Is that it? Like when you're not replacing the thing.
Maybe.
But factorial does that, where you multiply
Yeah,
the
is
combination.
factorial super polynomial?
Maybe?
I think it might be.
What was the
And less
equation
than
they had in the
exponential?
thing? Was that like a factorial? Did it have factorial in there? In the traveling?
Good question.
Where was it?
I feel like factorial is bigger than polynomial.
Oh, there you go.
Cool.
Polynomial factor n factorial. The factorial of the number of cities, so the solution becomes impractical even for. So this is when you do all the
Hey,
permutations, factorial, yeah.
hey, we worked it out. We're smart. Nice.
So it's not, um, yeah, it's not 2n or n squared, it's n factorial for the polynomial factor.
I think that 2 to the, sorry, 2 to the n squared is like, that's exponential.
Yeah, and it said it's not exponential, it's super polynomial, so
Right. So that
it can't
those
be that.
constraints made it like less than exponential.
Yeah, the constraints of not visiting the same city, so
Yeah.
without replacement, and also
That was
going
really
back
good to
to.
work that out, like bit by bit.
Hmm.
Yeah.
Yeah, well, we still have to come up with a solution.
Mm-hmm.
We'll leave that to another time. Anyway, that was good.
Yeah. Hey,
GG.
did you
See ya.